Let's practice with Kasia. Question. A spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks along the x-axis from the spotlight towards the building at the speed 1.4 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? Okay, first of all, let's set up a few things. Okay? Of course, we have to know the distance, okay, of the spotlight to the building is 12 meters. A man is 2 meters tall. That's quite high person. 1.4 meters per second is the speed, which actually is rate of change of the distance x with respect to time. And then the question asks how fast is the length of his shadow decreasing when he is 4 meters from the building. But 4 is just the description of that moment, that instant. He's still getting closer and closer to the building. Okay, what we will do? First of all, we will use some diagram. I can put the ground. This will be the spotlight. Okay, that dot is the spotlight. And let's say this is a wall. Okay, and now the man, I can maybe, it's 2 meters tall. Let's say that's him. And then he's walking. Yes, we can see he's moving along the x-axis towards the wall. And as soon as he's closer to the wall, I can kind of, maybe that will be his shadow. And it's closer and closer. And that we can see this distance is decreasing. That's what we're looking for, that height. Okay, let me remove and I will put just one triangle, the diagram that represents one moment, that instant. Okay, that's me again. That dot is the spotlight. Okay, this is building. This distance, of course, the entire distance, I can pick that color. This distance is 12 meters. Okay. Now we do have a guy, the person, which is 2 meters. That's the quantities that we can easily use. They are not gonna change. But what is changing? His speed, which is the distance, because he's moving this way. That means I'm assuming the distance behind him, that pink purple part, it's x. And the rate of change of x with respect to time, which is the speed, it's 1.4 meters per second. Okay. Which means if the purple part is x, then the remaining part, that bright yellow, will be 12 minus x, because from the entire 12, from the entire distance, I'm subtracting the purple x. Okay, and let's maybe put some labels. I will put that shadow on the building, I will name y, and we're looking how y is changing with respect to time at the moment when he is 4 meters away from the building. Which means if he is 4 meters away from the building, we can say that this bright green 12 minus x, it is 4 meters. Okay, this is at the moment. If that, I can possibly use the same color. Okay, if this distance 12 minus x is 4, and we can easily see that x is 8. Okay, that means if x is 8 meters, but of course he is 4 meters away. Okay, what we need? We need to find a relation between x, because that's given, and y, because that's what we're looking for. And we can nicely see two triangles, okay, the similar triangles, and let's put the relation. Okay, relation between x and y. I can say 2 meters, okay, I can say the height, I can draw this, that's x, that's 2, and then I have the big triangle. Okay, I do have the big triangle, which this is 12 and this is y. Okay, and then 2 over x, it's the same like y over 12. Height over base, height over base. Okay, and let's simplify. Okay, let's solve this equation for y. I will cross multiply x times y, 2 times 12, 24, and then dividing by x, I do have my equation for y. Now we need a relation between dy dt and dx dt. So what we will do, we will try to differentiate. Let's differentiate. I will differentiate with respect to t my left hand side, and I will differentiate with respect to t my right hand side, which function y and x is the function which depends on t. Okay, derivative of y, it's simply dy dt. Okay, and now what we have 24, I can write here, times 1 over x. 24 is constant. Okay, that's mean derivative, I can copy constant. And now derivative of 1 over x. 1 over x, it's simply x to the negative 1. Derivative of x to the negative 1 is negative 1 x to the negative 2, which is negative 1 over x squared. Negative 1 over x squared, however, times dx dt. Follow the chain rule. Okay, and now I believe is the moment that we can use all of the information. Dy dt, because we do have relation between derivatives. That's my proper relation. Okay, I will put negative 24, and then x, we're looking for dy dt at the moment, then x, we can see now, x is 8. Yes, we shouldn't use that quantity before. And of course, a quick comment, x is not 4, because 4 was the distance. 4 was the distance from the wall. Okay, that's mean we need x, and if his distance from the wall is 4, the remaining it's 8, and that's my x. Okay, that's mean I can put 8 squared, because x is, and the rate of change of x, which was his speed, it's 1.4. 1.4. Okay, dy dt, we do have negative 24, we have 8 times 8, and 1.4 is 14 over 10. I will use fractions because it's easier since we don't have a calculator. A little bit of simplification. 8 divided by 8 is 1, 24 divided by 8 is 3. What else I can do? I can try maybe divide by 2. 8 divided by 2 is 4, 14 divided by 2 is 7. Okay, let's just fraction. The rate of change of y with respect to time, which is the rate of change of the shadow on the building, it's negative because it's decreasing, and it's 21/40 meters per second. It's exactly the same like the units of the speed. Okay, and I believe that's the correct answer.